So you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. Today we're going to continue looking at CMI's Canadian branch. They're still arguing that the flood of Neue is a real event that was global in extent. They just finished pretending that the Grand Canyon could be caused by a flood, even though we know it absolutely couldn't based on its shape. Let's see what else they have for us.
Some of the layers exposed in Grand Canyon cover thousands of square miles in the US and can even be traced to England.
Yes, continents move, and deposition can be over a wide area, especially during sea transgressions, which is how we get large deposits of calm water submarine rock, like the aforementioned shales.
Rapid deposition of sediments is predicted in a global flood.
Yes.
Right, which is why things like non-flocculated shale, limestone, subaerial deposits, raindrop marks, ripple marks, animal tracks, etc., that are found in the Grand Canyon preclude the possibility of a flood. For the first, shale can be deposited rapidly, but only after floccules form. Floccules are little clumps of sediment that form suspended in the water column. You can kind of think of them like raindrops in a cloud. In a cloud where the water droplets are minuscule, the Brownian motion of the air keeps the cloud up in the sky, and so they tend not to drop to Earth. But if there is something around which a number of these minuscule drops can clump, a seed if you will, then they start to get bigger. Brownian motion starts to be unable to dominate over gravity, and the bigger drops start to fall as rain. Similarly, shale is made of incredibly fine-grained sediment, and normally such small sediments cannot settle to the bottom of a body of water unless the water is very still, and even then, they only settle out very slowly. But if there is something allowing these fine grains to stick together, they can precipitate out quite rapidly. But the thing there is that geologists can see floccules in shale, and the shales of the Grand Canyon don't have any. Limestone just can't form quickly, full stop. Ripple marks and raindrops can only be preserved if the sediment in which they formed dries out. Because otherwise, when you dump a bunch of mud from a flood on a bunch of other mud, you just get a bunch of mud, not mud on top of preserved ripples or raindrop marks. Animal tracks are part of a group of things called ichthyofossils. These are traces of life that are the result of the activity of organisms, but don't actually stem from the remains of organisms. One of the characteristics of flood deposits is that such things are not found in them. All of these things, including ichthyofossils, are found at the Grand Canyon, so again, it can't be formed from a flood.
And scientists find things like ripple marks, raindrop marks, and animal tracks in the rocks, things that would erode unless they got covered up quickly and preserved by more sediment.
I don't even know what to say. No, they don't have to be covered up quickly, at least not in human terms. If it rains on a sandy dune, then that dries out and lithifies. It can stay there for years as more sediment is deposited on top of it. Same for tracks and ripples. This is just the stupidest thing. I literally just spent a good while going over why these things preclude a flood as the cause of the geological column. And you know what? A young Earth creationist geologist agreed with me. Ichthyofossils and the like would preclude a formation from being a flood deposit. Sorry for all the creationists, but we find such things all through the sedimentary strata on Earth, and they're quite common.
A global flood would produce a global fossil record by rapidly burying plants and animals. Guess what? We see billions of fossils showing little decomposition. That means they must have been buried quickly, not slowly.
It can mean they were buried very quickly, but it doesn't need to. In fact, some of the best preserved fossils were buried slowly, but in anoxic environments. The best fossils are formed by slow deposition of fine-grained sediments in still anoxic environments. That's how we get things like the finely detailed feathers of Archaeopteryx in the Solnhofen limestone quarries.
It's commonly taught that it takes millions of years for a fossil to form.
Depends on what you mean. Many biomaterials that form fossils are already essentially rock, whether it be calcium carbonate, silica, or hydroxyapatite. In these cases, not much really needs to occur other than burial and subsequent lack of disturbance for a fossil to be found. Although over the course of time, there is a good chance that such materials may be replaced with other chemicals, making them permineralized fossil. Alternatively, the spaces within such a structure may fill in with other rock, making them another form of fossil. So some fossils take a long time to form, some don't.
But animals that die and don't get buried quickly get eaten by predators or they decompose. There's nothing left to fossilize.
Not necessarily. Let's take a look at Lake Natron in Tanzania. Now, if you know much about naturally occurring salts, you might know that natron is a kind of salt primarily composed of sodium carbonate decahydrate, and it was famously used as a main desiccating agent in ancient Egyptian mummification rituals. Why does this lake share the name of this salt? Well, because it's chock full of it and other salts. In fact, this is one of the hottest, most alkaline, and saltiest bodies of water on Earth. It has an exceptionally low biodiversity, with only 2 species of fish able to survive there, and a flock of flamingos depending on the lake to avoid predators, because most predators literally can't survive the trip to the flamingo's breeding ground. Now, these photographs you're seeing have been posed by the photographer, Nick Brandt, but he did not get the bodies to look that way. That's just how they look when they wash up on shore. Now, with a lake that has essentially no life, and that can coat living tissue in calcium in short order, let's say you died and fell into Lake Natron. If you don't wash to the shore, which isn't a guarantee, you'll sink to the bottom and be covered in calcium deposits. As time goes on, you'll be buried under more sediment, and nothing is likely to eat you. In fact, Lake Natron is almost certainly forming fossils right now that are slowly covered in sediment, and yet still not greatly scavenged. It's almost like there are a variety of ways fossils can form.
Now here's a fossil of a mother ichthyosaurus, like a dolphin, giving birth. Do you think it stayed in that position, giving birth for years as it was slowly buried?
No, I think it either died in childbirth, a thing that happens, or it died while pregnant and decomposition gases pushed the young ichthyosaur partway out during decomposition. Further, that fossil was hard to track down. First, the picture they're showing is from creation.com, CMI's website. Further complicating matters is that before putting this picture up on their website, they did all of the following. Inverted the hue, upped the saturation, increased the white levels, and X-mirrored it. The actual fossil looks like this. I can't think of many reasons to do this that aren't to make the fossil hard to track down. I do think I managed to find the publication describing the fossil. Unfortunately, it seems to be a book in German with no digitized edition. Fortunately, though, this seems to be a German specimen of Stenopterygius, an early Jurassic ichthyosaur. I did manage to find numerous papers describing locations in Germany for such fossil finds, but not for this specific specimen. Turns out that they're all from the Posidonia shale in southwest Germany. That shale is a bit coarser than some others, but shows no sign of flocculation, or at least I couldn't find a single paper mentioning floccules in that deposit. And so while it has probably deposited faster than, say, the Bright Angel shale, it still probably took a long time to deposit overall. So no, this fossil was not buried rapidly, because the rock it was found in couldn't have been deposited rapidly.
Here's a fossil octopus and a jellyfish. Now, they must have been buried quickly to preserve the soft tissue before it rotted.
Yes.
This is exactly what's expected in a global flood.
Exactly.
Before we get into these fossils, I just want to point out that so far, this video has had me chasing down sources in German, Russian, and Portuguese, and I'm bad at all of those languages. Can the obscure sources for once come in a language I can read reasonably well, like French, Spanish, or Catalan? So I was immediately suspicious of the claim that these fossils had to be buried rapidly, as I know from reading a lot of paleontology papers that the best preserved fossils tend to come from areas with very slow deposition, but also low levels of trophic activity associated with carrion. In other words, without many scavengers. Yay for big words! So when I finally traced this octopus down, it was preserved in limestone in Lebanon. Yup, a slow deposition environment. Now for the jellyfish, and what do you know, it's fine-grained limestone in an anoxic environment. Wow, who would have thought? Of course, my sources for this whole series are in the description, so if you don't believe me, check the peer-reviewed sources. I'd also like to point out that in layers other than the ones where this jellyfish was preserved, there is evidence of extensive bioturbation, which, a flood would erase. So yeah, not a flood deposit. Funny how every time I look up a fossil, creationists say is the result of rapid burial because of how well preserved it is. The exact opposite is true.
And then there are polystrate fossils, fossils that run through multiple layers of rock.
Nope, not going to do this one again. This has been covered by basically everyone. Check the cards or descriptions if you want to see it covered by various people. The whole point has been moot since 1968. About 150 years ago. I refuse to once again do polystrate trees.
But what about Hutton's idea that sedimentation has always been a slow process?
It's an idea, yeah.
Yup, and it's wrong. Modern geologists don't tend to hold to the idea that sedimentation is always slow. They say it's slow when the physics and chemistry of rocks and deposition require it to be, like in fine-grained siltstone or limestone, and rapid when it's indicated, such as in turbidite conglomerates or tsunamite, or in the case of rapid deposition of tuff.
When Mount St. Helens erupted in 1980, we saw that layers of sediment can form rapidly.
Seriously, what did I just say about tuff? No geologist thinks that tuff, which is what this is, or rather what it will be when it lithifies, has to be deposited slowly. Find me the volcano that spews out limestone and we'll talk. Seriously, this is as stupid as saying that since you can play a hand of poker in 10 minutes, that the game of Monopoly will also take 10 minutes. Different kinds of rock form in different ways, under different circumstances, at different rates. That's what makes them different kinds of rock in the first place.
The layer that you see there between the dotted lines, that was laid down in about 3 hours on June 12, 1980. Here's a close-up. Look at the fine layers.
Yeah, look at the fine layers. No one is surprised that ash deposits are laminated. Another thing, which I'm not sure will come up, but which I suspect will, is that this ash isn't actually rock yet. You can see it crumbled right there in this picture. This is still unconsolidated ash, and it will be many years until it is actually rock.
Normally, 1 or 2 of those thin layers get laid down per year, but here, they're within a 20-foot thick block deposited in 3 hours.
What are you going on about, Richard? That's that guy's name, by the way. No one is suggesting that subaerial ash is being laid down constantly at a rate of a few inches a year for years anywhere. That would require a continuous volcanic eruption spewing ash at a consistent rate for decades. Where has anyone ever proposed this to explain tough or tufaceous rock? I'm unaware of any such proposal.
That's some fast deposition.
It is.
Now, it helps us understand what a global flood might be capable of on a much larger scale.
Yes.
Yeah, if ever there were two phenomena more indistinguishable than a flood of water and a rain of volcanic ash, I've never heard of it. They're basically the same thing. I don't even know why we have different words to describe the events.
Also, mud flows from the volcano carved a canyon through the existing layers, also in a single day. The river that you see in the canyon today had nothing to do with its formation.
Yeah, smooth wall channels can be cut out of soft, unconsolidated sediment rapidly. No one objects to this. But how do you explain all the steep-channeled, jagged ravines and canyons? You can't do it with rapid-flowing water through unconsolidated material. Again, this is just conflating two superficially similar phenomena that have hugely different causes and actual outcomes.
It didn't even exist before the canyon.
Yeah.
It's caused by the rainfall collecting in the canyon after it was formed. So instead of the river causing the canyon caused the river.
Yup, and that doesn't help your point at all, so I'm not sure what all the smugness is about.
Yeah, more support for rapid deposition is seen in bent layers of rock. Here's an example from Auckland, New Zealand. It's very hard to bend solid rock. If they form slowly over millions of years, there should be signs of cracking, but there aren't.
No.
A global flood is a much better cause. The layers were deposited rapidly and then bent while they were still soft.
So if layers of sediment are bent while they are still soft or unconsolidated, then they will tend to merge together as the areas where different deposits touch. They will no longer be distinct layers. Instead, they will smoothly transition into each other, which isn't what we see in the examples creationists like to cite, this one included. Further, if they were bent rapidly after consolidation, they would fracture. Again, not what we see. Instead, this has to happen in high heat and pressure, both of which increase the plasticity of rock, allowing it to bend. In fact, we even have fossil bones that are distorted in ways that match the bent sediment. Linked in the description is a PLOS One paper specifically analyzing plastic deformation of ankylosaur skulls, and I think we all know that ankylosaur skulls, and indeed would have cracked under normal conditions if compressed. Instead, these, along with the rock, have plastically deformed, and if the deformation of the rock had occurred when the layers were still unlithified, the skull would be unchanged. So no, this whole point is nonsense.
Now, things have changed since Hutton. Many non-Christian geologists now admit that most of the geologic record was formed by catastrophe.
Yes.
I mean, it depends on what you mean by much. Certainly a lot of material out there is from events like floods, volcanoes, etc., but even more of it is made by just seasonal deposition from things like rivers, lakes, lagoons, estuaries, and the ocean floor.
But rather than admit a global flood, they say many catastrophes happened with gaps of millions of years between the layers.
Yeah.
Well, when you see unconformities between layers, and both relative and absolute dating tells you that the layers are of significantly different age, what other conclusion can you come to? That despite being different kinds of deposition with erosion between them, meaning they had time to turn to rock, then wear away, then be covered again, that all this happened in one event? That is actually insane. You would have to break from reality to seriously entertain this as an option. It's not even an ontological possibility as far as I can tell. Like, even if you attribute it all to miracles, that means it's not all caused by one geological event. It's caused by non-geological processes. Even an omnipotent God couldn't make a global flood result in the strata we observed. the best such a being could do would be to have a flood, erase all evidence of it, then plant evidence that contradicts it.
Yet there's little to no evidence for gaps, things like erosion and soil formation.
Unconformities, which is what you call it when erosion separates two strata, are found all over the place, as are soil horizons and paleosols. This is just a straight up lie, and honestly, it's on the level of claiming that clouds don't exist. There's not even a point in citing this. There are literally thousands of papers reporting on unconformities, paleolandscapes, infill channels, paleosols, soil horizons, etc. If I tried to list even a fraction of them, I'd be here for years just copy-pasting the citations to articles. I think we're going to leave CMI here for now. I hope you enjoyed this video, and if you did, please hit the like button and tell me about it in the comments. If you didn't like it, then hit the dislike button and let me know why you didn't. Either way, please share the video and subscribe with the subscribe button below this video. Hit the bell icon and remember to turn on all notifications so you're always notified when there's new Dapper Dino content. I'm the Dapper Dinosaur. I just want to take a moment to thank my patrons and channel members, especially those pledging $20 or above: Bob Knob, Bent Hovind, Ian Chen, Chris Love, Sphincter of Doom, The Venerable Bede, and Patrick Dennis. My patrons and channel members really help make this channel possible, and without them, this channel wouldn't exist. If you would like to support me, you can click the join link on this channel below this video, or you can click on my Patreon, link in the description, and pledge. On Patreon, there is an option for an annual subscription, which comes with a 10% discount. And joining the channel will give you access to my custom emojis. However, if a regular pledge isn't for you, I do have a merch store. And if monetarily helping out the channel isn't a thing you can do, every like, share, and comment really helps the channel.